The broadcast is now starting. All attendees are in listen-only mode.
Hello? Can you hear? Okay, perfect. Sorry for this. I hope me now. I'll repeat again what regarding Internet of Things Egypt Forum. So today we are hosting the Massive IoT and the Rotary seminar or webinar. My name is Wael Ammar from Sigfox. I'm director for Egypt, Saudi Arabia, and Iraq. And today I will take you through Sigfox technology and the way we view massive IoT deployments and the road to a smart country. So thanks everybody for attending today, and thanks for Internet of Things Egypt for hosting this webinar. Let me start a little bit brief about myself. My name, as you know, is Wael Ammar. I have over 23 years experience in the ICT field across emerging markets in Asia, Africa, and Middle East. I worked for several reputed organizations like Apple, Siemens, and Etisalat Group, and recently I've joined Sigfox in 2017 beginning, heading the regional activities for the three countries, the biggest three countries in Middle East, pretty much Egypt, Saudi Arabia, and I have participated in various exciting startup launches. Some of you may have known them, like GigaNet in the early stages of the ISP business in Egypt, now known as TE Data. I've also was heading the commercial activities for the launch of Etisalat in Nigeria, one of the largest or the largest populous country in Nigeria, in Africa. We have launched there Etisalat, and I have an engineering degree from Ain Shams University here in Cairo, Egypt, and with a major in computer engineering and automatic controls, and has also executive educations in Cranfield University for management and leadership. So looking at the agenda today, we'll take you through the vision for the basis for how IoT should work in a territory or a country. And that's one of the key important aspects of the success of IoT and massive IoT adoption. Let me start quickly with our vision. We have in Sigfox, as you see the picture, this is the CEO and the CSO, which is we call him the Chief Scientist Officer. So these are the two guys who have started the whole journey of Sigfox. Christoph is the guy behind the technology. He's the scientist, so he developed the technology. And Ludovic, the CEO, who sees the view and vision and how to make use of this technology, amazing technology that was developed to deploy IoT on a global level. So they have that term which they call power of law. Well, that's the motto in Sigfox. And it is all about making things simple, low cost and low power in terms of the consumptions of energy. As you know, that's a key and challenging aspect of deployment of IoT is the utilization of energy and the need for energy sources to power the devices and the sensors. But we have a view of and bringing deployment in use cases that were never possible to think about into reality. So look, some key facts about Sigfox itself. So we were a French company, as you may know. We have been established and created in 2009. Today, after almost 8 years of operation, developing the technology, we started the view of how we want to use this technology on a global level for deploying IoT in a massive scale. So there have been a lot of excited investors behind our company. We are kind of a global startup, you can assume that. We are still in the fundraising exercises, and we have raised more than 277 million euros in terms of fund. Today we have over 384 employees in Sigfox on a global level. We have our headquarters is in Toulouse, and we have lots of other offices, regional offices responsible for different regions of the world, like in Singapore, San Francisco, Paris, and Dubai. And Dubai office, where I belong to, that team in Dubai is responsible for Middle East and Africa. We have lots of industry vertical investors across different verticals in the globe: oil and gas, electronics, satellite, IT, financial institutions who are shareholders in our company and have invested in our company because they believe in the vision of IoT and the massive future that IoT holds. And today, which is a key and important part of our success today and the success of any IoT platform that is deployed or have a view of a global and mass adoption of IoT, is the ecosystem. And today we have a very rich ecosystem and growing partners who are developing different solutions and devices and sensors and platforms and end-to-end solutions for IoT. If we take a quick look background on when we started the whole idea of rolling out IoT networks on a global level. This has started as recent as in 2014 when we started to deploy our countrywide network in France, and that was our first encounter. We want to prove that this technology is working and can achieve lots of success. So we started with France, our head office, where our head office is, and we deployed a nationwide network dedicated for IoT and connectivity of things to the internet. We seen that proven, and we started to expand globally. Today we have reached about 36 countries as we speak today, cutting across the various continents on a global level. And we hope that by end of 2018, we would have 60 countries fully covered with Sigfox technology. Our vision and our approach and strategy is to go and put infrastructure to cover the network in a specific country with full coverage. And that's IoT use cases to be innovated, developed, and also address existing needs of countries who have view and vision for IoT deployment of smart cities and using IoT as a solution to today's problems. So if we look out of the 36 countries, we have of their territory, geographical territory, and population coverage. As you see, there is a massive increase in terms of population covered as we are expanding globally, and the territories as well. So lots of exciting things to come, and lots of new ideas and use cases that are generated every day from our customers or from our teams globally who sees and deploys and thinks and work together with the client on solving their problems using IoT. So this is just a map showing the footprint. So as you can see, we are in the US, Mexico, LATAM in terms of Brazil, Argentina, Chile, and Colombia, and we are expanding very, very well there. In Europe, of course, most of West Europe, like Spain, France, UK, Ireland, Italy, Denmark, Germany are all expanding and having lots of networks and coverage deployed. Middle East and Africa have also existing countries that have already started deploying or covering their territory, like Oman, Iran, South Africa. In Asia Pac, we have also like Australia, New Zealand, South Korea, Thailand, Singapore, Hong Kong, and Taiwan are all having their network. So as you can see, we are having a global footprint with lots of countries with advanced economies, and even existing technologies have seen what Sigfox has able to offer and what kind of advantages our technology is able to bring to IoT in a simple and cost-efficient way. So let's talk now about connecting things to the internet. We today hear about lots of different technologies deployed or to be deployed and announced, and all having the promise of massive IoT adoptions, and this is brings solution. The reality is that from our view, we see that there is no one solution that fits everything, and that includes Sigfox as well. You will find lots of different use cases that possibly Sigfox is not able to address. And there are other use cases which are more fit for our technology to address. And that's how the whole idea of IoT going through. It's an ecosystem of technologies and partners who work together to solve a client problem. And at the end, the whole interoperability and standards is not about devices talking to each other, and it's not about my technology talks to the other technology. It's all the integrity of the data and the ability of the customer to interpret the data collected, no matter what communication medium he's using or what kind of technology he's using, and be able to make right decisions and take actions according to the data. So the most important part of the whole story is that the data collected using these devices and sensors that are deployed in various locations and use cases are the key part for the customer. And as long as the data is interoperable and people are with capabilities to do the right decisions and analytics, then that's what we all are gearing for. So there are getting insights that helps you with enhancing the performance of your business, cutting costs or increasing revenues. And at the end, there is a potential opportunity of also using autonomous decision making in cases where you want to deploy artificial intelligence based on analytics that you have been able to develop and capture the data related to that, and taking decision more on an automated level. So these are the different 4 stages of people who are deploying IoT and where they should be gearing for empowering of their possibilities. So anybody who's looking, or any customer who is looking, needs to do the IoT. So at the end, the results are going to be about either cost reduction or process optimization or a value creation. So there is an opportunity by deploying this IoT, you're able to create value to your end users, or you have able to optimize the process or reducing the cost of your enterprise. And this is actually, nobody wants to deploy IoT for the sake of IoT. It's all about solving business problems. So whoever is trying to sell an IoT solution to a client or a customer has to really be understanding the business he is in and trying to understand his pain points and be able to address that by using innovative solutions using IoT. So looking at the ecosystem of IoT and quickly going through the different things. So there will be on the left side here, we are talking about the devices, the connectivity, and data processing. Okay, so these are the different value chain or ecosystem behind the IoT. And in each one of those, there is lots of providers can be used to solve the customer problem. So where does Sigfox fit into this equation? We are on the second point, which is more about connectivity. So Sigfox comes with its technology to provide connectivity and giving efficient transmission of information from the device side up till the application at the customer side. And this is where we are focused on, and this is where our technology is being deployed globally to achieve such a process or such a goal. So we can categorize ourselves as an IoT operator, providing connectivity and a little bit of middleware, because this is where the processing of information and intelligence of information to send the collected data to the client side utilizing our cloud capabilities. And across the board or the value chain, of course, security from an end-to-end perspective is a key component of our offering and a key important factor that we always have to look at because in IoT security needs to be taken care of on a global level. So what is our business exactly? So if I quickly take you through this, we as Sigfox are offering a technology to provide connectivity. And this connectivity has 2 sides of it. One is given to the left side, which are the people who are making devices or the partners, ecosystem partners who are putting devices to do sensing activities or measuring activities of data at the field side. And these are a lot of partners that we have and globally existing and increasing by the day. And this we offer our technology to them free of charge in a way that we don't charge for. So there is the Sigfox communication module, which is developed by Sigfox and given without any IPR to all the chip manufacturing facilities or partners we have, like Texas Instruments, Intel, NXP, Incom, Weisel, lots on a global level in various locations, geographies of the world. And they deploy our Sigfox library in their chipset modules to allow integration with their devices to send radio wireless communication over our network. And then the device makers who are actually making the devices, like smart meters, could be water meters, sensing devices that is measuring temperature or humidity or air want to send this information from the field, they would integrate that Sigfox module in their equipment or devices and be able to communicate wirelessly using the Sigfox network. And we, on that side, we offer them that free of charge, and we certify their devices to ensure that they are conforming to the standards and quality measures that we have, as well as trying to ensure that security with the certification of those devices, because at that each device will have its ID, and at that time Sigfox with the certification is able to offer the device a unique ID to be able to communicate on them. It's a big concern when it comes to security for gray devices or people who are making dummy devices outside the ecosystem and trying to deploy unknown devices on the network. So that's a very key component of our security approach. On the second side, the platform providers, those who are collecting the data on the client side and want to receive the data that was sent by their devices or sensors in the field. So those platform providers, we also certify them to communicate with our cloud infrastructure and ensure that they are able to read the data sent specifically to their client side and to retrieve it at the location or at the customer application. So we deal with two sides of the story, and we are the communication medium in between in summary. So what are the key goals or the pillars that would help in successful deployment of massive IoT? So there is lots of different applications for IoT. We know about smart cities, what utilities, smart utilities. There is things has to do that have to do with autonomous driving. There is lots of things has to do with service. So where does Sigfox fit? I mean, our technology, as I mentioned, is not fit for every use case, but it could potentially address a large part of the use cases that are at the bottom of the pyramid, which represents the massive IoT deployment in new ideas and new cases where it doesn't need huge bandwidths or a lot of processing power. So to deploy IoT on a massive scale, you need to address 4 pillars so that you have a successful story and also avoid any challenging issues. So first of all, the cost, which means that the cost to deploy an IoT device or devices for IoT to solve a customer problem has to be affordable, as well as the connectivity itself has to be affordable. You cannot be charging over $10 or $5 per month to deploy millions of devices in the field, whatever the use case is, because it becomes a very uphill task for people to adopt this on a mass scale, and hence the benefit is not there. Also, the cost of the device itself, making the device, putting the communication modules inside is a key component for the value of that device at the end. Second is most of these devices that are put in the field might not necessarily, or let's say majority of them might not necessarily have access to power source to power the device itself. So they depend on batteries. And hence, if your solution and technology used is draining your battery faster, this means a lot of costs related to administrative tasks and the logistics of deploying and checking on those devices, changing batteries every now and then. So by design, the IoT solution and communication should address this issue of current drain or energy drain by trying to elongate the lifetime of your battery in the field. Otherwise, it becomes very hectic and unuseful to a large extent. or you need to even manage logistics like SIM cards in case if we are talking about GSM technologies, because it is still today on a massive scale, the use of eSIM is still not widely used. And hence, the simplicity component of managing your device in the field is a key parameter to the success. So, if we are talking about where does Sigfox compare to the existing technologies that are being used for IoT or being promised to be the effective solution for IoT, we have the story, those who are providing energy and for mass deployment, and this cuts across the different existing today's technology like Bluetooth, Wi-Fi, Zigbee, and all this work and are considered into what we call a LAN network or a private network without the capability to send information over a wide area network. And we call them the personal private network. And then we have the other technologies, existing technologies or coming technologies like the 2G, 3G, 4G networks of the mobile operators, of course, and this provides you the required scale, the required distance to send information over a longer distance, but not necessarily energy efficient at this stage until the promised future technologies of 5G come into the picture and still under standardization. And then there is the what we call the low power wide area technologies that have been launched recently, like the LoRa, the Ingenio, and Sigfox today. And this is what we call as public connectivity, so something that you can massively deploy in a territory and address multiple use cases with massive population without the need to do private area networks in that. So what are the different advantages of low power WAN technologies, whether it is Ingenio, LoRa, or Sigfox versus the other one? There are two more important aspects of it, which puts it in a very good comparison and competition with other technologies, which has to do with mobile-based or 3GPP technologies, as we call them, which has to do with of course, the energy efficiency, the geographical coverage and penetration, and the range of the communication. And on the other side, technologies has more advantages in terms of their bandwidth and latency, of course. And hence, that specifies exactly where and when you should be using which technologies. There is lots of situation where you cannot use a low power WAN technologies like Sigfox when it comes to video camera and transmission, which requires a huge bandwidth and high bandwidth of transmission for surveillance activities, and also something like autonomous driving. But if you are looking for some sort of utilities IoT deployment or solutions where the smart meter for the water or gas or maybe electricity, you want to send a reading once a day, and that reading is just some few bytes, then this is where you don't really need huge bandwidth and low latency network infrastructure, but rather a more efficient and cost-effective solution to deploy this on a massive scale. And hence you could consider in that case the low power WAN technologies available. So if we move, just to give you an idea about specifically Sigfox in that sense, and on a very simplistic diagram. So we have on the left side here the object data, which is the information we want to retrieve from the field. So you deploy sensors devices for tracking on an oil rig in an agriculture farm, or any water utility company, or a gas metering company. And then the object data gets transmitted. So we have the payload for the Sigfox is ranging between 0 to 12 byte. So each message or Sigfox message that is sent from the device or sensor data available at the field, you can send information per message from 0 to 12 bytes. Okay. Some of you might think that this is a very small payload, but actually if you think thoroughly through it, you will find it more than enough to send whatever required information. I will show you how. Then this transmitted through radio, public spectrum, we call it. So it uses what we call an unlicensed spectrum, similar to the Wi-Fi, but it is below the 1 gigahertz spectrum. It's called the ISM band on the unlicensed spectrum as per the ITU definitions. And for different reasons that I will come to later, is that able from 0 to 140 messages. Okay, then those messages are received by the Sigfox access station covering this region or territory, which can process over 1 million messages per day, per base stations per day. This information is transmitted to our Sigfox cloud, which ensures the integrity, security of this data, making sure that the devices are sent, have been already identified on the network, and forwards, or the platform on the client side pulls this data after integrity checks and authentications and security analysis to the customer side analytics platform, and then to the customer IT application. So how does the operating model of Sigfox work, and how does the service reach its customers at the end? So Sigfox, as a global operator of IoT, does not operate networks by itself. We do this through partnership programs. So the Sigfox have 3 countries where it operates its network by itself through a Sigfox operator, 100% owned by Sigfox. And this is pretty much in France, Germany, and the US. And those were the first 3 countries where we wanted to deploy and make sure that the technology is working well, and to prove the concept to other potential investors that this thing is going in the right direction. After that, the plan and how we expanded to 37 or 36 countries as of today through partnership programs, where we partner with what we call Sigfox operator in a specific country or a territory, and he does part of the investment, and we come with our technology and cloud infrastructure to jointly operate that local part of the global network. And that Sigfox operators takes the full responsibility about the network operation in that territory, including all the marketing and sales and appointing of channel partners who are selling solutions to the end customers. And those channel partners could be system integrators, telecom service providers, could be device manufacturing who are manufacturing smart metering, for example. Anybody who's giving solutions in the field of ICT and IoT. Okay. And this is pretty much how the model is working. Moving forward, we all know about how the growth of IoT is, and different figures have been published by different advisory and consultancy firms. But it is very interesting to understand that the fold of information and flow of information is going to be, more than 10 times in cases of IoT, is going to be 49 times. But I have highlighted here this red circle on the right side just to show you the difference between total data and the IoT data. And that proves to you that despite the fact that IoT data is going to be 49 times the current rates, and the broadband data in general is going to be 10 times, but this absolute value is actually smaller than the total value of increase. It shows you that this IoT data is mainly not about huge band network technologies. This slide shows it's coming from Ericsson Mobility Report in June 2016, and we all know Ericsson. They are one of the leading 3GPP standard followers and GSM providers and solution providers to telecom operators. And that report shows that cellular IoT is going to be increasing by 2024 by 27%, or 2015 to 2021, they're going to grow by 27%, while non-cellular IoT, which means that is not GSM-based or 3GPP standards, will also grow by 22%. But devices, out of the 28 billion, is going to be at least half of it is happening non-cellular IoT. And that gives an indication that also the LP1 technology coexistence with existing and future 3GPP technologies, whether for complementary or for addressing use cases specifically geared for low power WAN. If we look at this slide, we can see lots of use cases where low power WAN and other technologies could coexist for backup purposes or for addressing specific situations that the technology is able to address in specific situations. And I'm going to be talking about one or two of those use cases just in few minutes ahead. So as you can see, the Sigfox low power WAN, according to Machina report of December 2015, it talks about 2.7 billion low power WAN connections that could be addressed by Sigfox technology, but it opens also the opportunity for complementing Sigfox with other technologies like the personal area network technologies like Wi-Fi, Zigbee, or Bluetooth for short range devices. And this is expand the market to 18.5 billion. Also, if we look at the situation with cellular, whether GSM or LTE based, this is another 2.2 billion opportunity, and other technologies that could coexist with LP1 and Sigfox in that scenario. If we look specifically to Egypt market, based on Machina research, also 2015, they look at the market by 2024 to have over 98 million possible M2M connections, out of which 44.3 million could be addressed using low power WAN. You can see that Egypt has a huge potential for deploying IoT on a massive scale, and also the possibility to address those use cases using low power WAN technologies. If we go a little bit granular on the breakdown for what kind of use cases and which areas of interest that you could easily address using low power WAN technologies and IoT, that comes into building automation, building security. I understand there's lots of smart compounds initiatives in Egypt, and also smart utilities initiatives that could definitely bring lots of IoT deployment opportunities. Also in the area of white goods like fridges, washing machines connected to the Internet of Things, using LP1 technology is possible also. And definitely other equipment and asset management and smart logistics that could potentially be deployed in Egypt, being a corridor for trade, whether through the Suez Canal and the other initiatives which the government is taking big strides into. So leaving now the pretty much overview about Sigfox and the various opportunities there, I want to talk a little bit more about our technology and how we are addressing that from a technical perspective. It's not deep technical, but at least it gives you an understanding of how our technology is working. So pretty much we are considered an ultra narrow band technology, which means that we are not all about high bandwidth and high speed connectivity for data. No, we are actually a very low throughput, low bandwidth technology that is optimized for IoT devices connectivity. So we operate in the sub-gigahertz spectrum, and all we need of information or bandwidth in that spectrum is 200 kilohertz, part of the spectrum. The spectrum is what we call the ISM band between 868 to point something and to 868 to 0.2. So all we need to be able to cover all the potential connected devices in a country, in any country, we need is 200 kilohertz. T per message takes about 1 hertz of bandwidth. So which is, this is the 1 bit per second in terms of the speed. You can assume that that's a very speed connectivity. And each message takes about 100 hertz. So in any given time, you have 192 kilohertz wide of a channel. You can send about 2,000 messages simultaneously at any given time. And this gives you a huge scale and huge number of connected devices that you are able to transmit using very low bandwidths and very small amount of spectrum. So it is very spectrum efficient. And that's one of the key design parameters that we have put, because the more bandwidth you use, the more processing power you need, and that's your battery life as well. So it's all taken into consideration of how to be as efficient as possible to transmit the required information without utilizing too much power. Second thing, we have what we call a random access. The difference between the low power WAN technology of Sigfox and a comparable technology, maybe using GSM or any of things, is that there is no synchronization between the network and the devices. So no signaling is happening, because signaling between device and means that you will need to consume more power, because the device is always on status, and that drains the battery. So we came up with an approach that would guarantee the quality of our service and transmission of messages without the need to create such overhead on the protocol itself. So we have what we call an nice transmission between the network and the device. So the device wakes up whenever the event happens or triggers and sends the information. But because we don't use what other technologies use, like acknowledgement of receipt of this message, so we need to do it in a different way that is more efficient to minimize the need for the device to wait for an acknowledgement from the network and keep it in a wake status. So in that case, what happens is that within the frequency band of the 200 kilohertz, whenever a device sends a message, it's going to send it 3 times. So you get a time diversity in terms of sending the message, and he will send it at 3 different frequency, random frequency chosen by the device within the spectrum that he's operating into. So you got time diversity and frequency diversity. The second part also, which means that you want to also ensure from a network side that you are covering that device. So each of those messages within the network design of how we deploy the network in a specific territory, we ensure that at least the message is received by 3 adjacent base stations. So in that case, you also increase the chances in terms of that this message gets delivered without the need to initiate any downlink or acknowledgement message 6 seconds. And the device sleeps in a sleep mode without any power drainage until the next cycle where he's supposed to be sending. Okay, and that's how we ensure the receiving of the message in a very high probability rate, more than 99.9%, without the need to acknowledge to the through the network. And that's, of course, saves the battery life of the device and keep it more simple in terms of the design and as well as the cost. So if we look at the small messages, we talked about 12 bytes, and I mentioned to you that 12 bytes is more than enough to send lots of information within that. So the protocol allows you to the network, and this could send the sensor data itself. It could send the event status, GPS fix, and application data. And this uses what we call a 1% duty cycle for objects. So that's specified by the regulations of the ITU when you are using the unlicensed spectrum or the ISM band where we are operating on, because it's a shared bandwidth and it could include other technologies using it, similar to the Wi-Fi concept, the 2.4 and 5 gigahertz. There could be lots of other technologies using the same spectrum, but it's shared. So you have to respect the amount of time that each device is using that spectrum. So they have a specific duty cycle, which means that per hour you are able to send up to 6 messages per device. On the downlink, also there is a possibility if the application wants information to the device to change its configuration, to trigger something, there is a possibility that you can also send a downlink. So it's a bidirectional communication. But in that case, it is an 8-byte payload, not 12 like the uplink. And it uses what we call a 10% duty cycle for base station. So the base station in that case talking to the device through the application at the customer side. And if we want to see what kind of information we can send through 12 byte, so if you want to send the GPS coordinates, for example, if you are doing any tracking activities or something like that, you will be using 6 bytes. If you want to send a temperature reporting, you will be using 2 bytes. If you want to send the speed of movement, you will be sending 1 byte. And then you can send the state of the object itself, if it's moving or standing still or vibrating or anything, that would be taking 1 byte. And then you can send 0 byte just as a heartbeat to ensure that this device is still working, or what's the status of the battery, for example. So this is what you can all send in a 12 byte, which is more than enough information if we are talking about simple measurement devices, sensor devices in the field doing very dedicated tasks to it. We mentioned that this communication bidirectional, so there is a possibility that you can send back to the device requesting either to change of configuration or even to design that if you decide from an application point of view that you need to ensure acknowledgement of receipt of data so that the device may want to resend again the data based on an acknowledgement, and that would be in specific use cases. That is possible to be done, and you can still send an acknowledgement message back to the device to inform them that the message has been received. It's available as a feature, and it's depending on the use case and the design. But of course, any of those things from a parameter point of view of design, you need to ensure that it doesn't compromise your real need of long battery life. So in that sense, how the acknowledgement or the downlink works, it's all device initiated. So the network does not communicate at all with the device, and I will explain that how it happens or why it happens due to the security by design, where we are addressing Sigfox security issues. But that's something that you cannot reach the device from the network side, except that the device initiates the downlink communication. So the device decides when to send, and the device itself decides when to receive information from the network side or the application side. So in that case, he sends a message, uplink message, to tell them that I'm ready to receive, and then they send him the information. send the information. It's a flat architecture network, so you got the sensor data talking to the base stations. Each base station is directly connected to the cloud, and the cloud is connected to the customer platform where he retrieves his data back through callbacks and HTTPS calls from the message storage side. So why we say that this is a high network capacity, because you got the ultra narrow band spectrum. In that case, you are able within the 200 kilohertz send lots of different messages simultaneously instead of utilizing the 200 kilohertz, for example, in other technologies to send one message. We are using this 200 kilohertz to be able to send 2,000 simultaneous messages. You get the frequency and time diversity and spatial diversity of the base stations, which creates you the opportunity to have even a larger scale and capacity to receive messages from millions of devices deployed in a specific area. Okay, and in that case, no matter what is the number of messages received or where the device sits, whether at the edge of the network or at the beginning of the network, because we have a standard payload size that doesn't change with the message. So in that case, and the data rate is fixed, you will find that the capacity and number of messages per station remains constant no matter where the device is located within the coverage area. So in some other technologies, for example, if you are very closer to the network, you get higher bandwidth. If you are very far, you get lower bandwidth. And that's pretty much affects the capacity of the base station itself, or the coverage also, penetration within the area of coverage. So maybe you will find if you, in some area, if there is lots of people, this message or the cell size shrinks because there is lots of people connected already. So you have an effect on indoor coverage in that case, which doesn't happen in the case of the low power WAN Sigfox technology that we are talking about today. Again, looking at the idle state of a device, we assume that 99.x% of the time the device will be in an idle state. Only consumes about 30 milliamperes when it needs to send the information, and then goes back to sleep. So it is the 6 seconds communication state, which each message he sends or the device sends is 2 seconds, and you multiply this by 3, so because it sends 3 times on 3 different time slots. So the wake up time is 6 seconds, and then it goes back to sleep until the next cycle. So during the sleep mode, the power consumption is in the 6 nanoampere almost. When it's transmitting for 6 seconds, it uses about 30 milliampere, which is the device power, allowed power for transmission during within the unlicensed spectrum band as per the regulations. As I mentioned, the beauty of low power WAN and sub-gigahertz spectrum is that you are able to travel long range with the same device. So using ultra narrow band technology and using small payload size and small bandwidths, and putting the power consumption within the allowed limit of 25 milliwatt as per the regulations, allows the signal to travel a longer distance. So it is a compromise, as we know, between the power, the range, and the bandwidth. And because we are using ultra narrow band, it's able to travel a longer distance. So you have good link budgets in that sense for indoor coverage and for long distances, depending, of course, on the dense urban and rural kind of clutter for the radio propagation. concentrated power in a small bandwidth signal, it's able to penetrate through this noise and be recognized by our base stations. In addition to that, that is very resilient to jamming. So it is very difficult to jam the signal that is generated from the devices to the base station, unless you are using what we call a military grade kind of or law enforcement grade kind of jammers to be able to block that. So you need more than 1,000 watt kind of jammers to be able to stop the signal from propagating and reaching our base stations, which means that in certain cases, and we have a very nice use case for a customer who's offering home security, was depending purely on GSM, and in that case, the thieves or the burglars were buying very low-cost handheld kind of GSM jammers to block the signal and not send the alarm until they finish, and it was almost too late to recover the stolen assets. They have decided to go with a complementary GSM plus Sigfox, and in that case, it's a complementary solution. So when the device detects there is a jamming signal on the GSM, will send the alert using the Sigfox network, which is able to bypass this jamming signal and be received by the law enforcement or security monitoring stations. So we can speak a little bit about the security by design in our technology, so that we are able to address one of the important things that is definitely having a lot of focus from anybody who wants to deploy IoT. We know that security is an end-to-end requirement. It starts from the device and up till the application level and whatever is in between. And as we deploy more devices, the risk of huge surface attacks are exploding. But what we need to be taking care into in the design and the choosing the right technology to be able to minimize. I'm not sure that we can eliminate everything, but at least by design, we should be able to minimize any loopholes that could affect such decisions of deployment, because at one point of time we need to achieve the results of IoT, but we are very concerned about security, understand the technology. So it is very good that we need to look at the risk analysis to strike the right balance and make sure that the risk and effort and cost are compatible in that sense. So if we look at the Sigfox security, it's what we call security by design or security by default, and it cuts across the whole ecosystem and the stream between the data generated from the device up till the data reaching the customer side. And this addresses privacy, integrity, authentication, and confidentiality of course, of the information. So we have 3-level embedded security that is done on the device. There is, of course, protection of the data during radio transmission between the base stations and to the cloud, and then from the cloud to the customer side. So in terms of data encryption, there is a possibility that you do an end-to-end encryption using your application and your own algorithms, but also you can utilize the algorithm available on the Sigfox library and protocol, which is available on the device, and use that to encrypt the communication between the device up till the base station. And then from the device up till actually the cloud through the base station, which is already protected and transmission protected using IPVPN to the cloud. So we have design choices that we have addressed for the security. Of course, we have IT strategy and technology policies that we deploy. Let me take you through some of the design choices. So we call it's a built-in firewall. So the first thing is that any Sigfox ready device is not connected through IP. So there is no IP address, is not the device is not connected to the internet, and there is no way that you can reach this device from the internet at all because it's not using IP. Okay, so the second part, as I mentioned earlier, is that the device initiates the communication, and it has a small payload and a low bit rate and random frequency. There is anti-jamming, there is prevention from denial of service attacks. And if we look at DDoS, or distributed denial of service attacks, it requires that you take control of a device, and that device takes control of the other devices and start through broadband connectivity using huge bandwidths. That's by default in any payload or any low power WAN technology, because even in the worst case scenario, and I don't see this even happening in such non-IP technologies, is to take a control of the device. Even if you want to initiate a massive attack, you don't have that bandwidth to do it. Plus, the device will not allow you to do that because it respects the duty cycle of sending a 12-byte message every 10 minutes on the max. So this is not something that you can use to do a denial of or distributed denial of service attacks. Plus that the device always initiates the communication, so this means that you need to take control of the device in a different completely manner than it is an outside hacking attempt from outside. The random frequencies, which means that if you even want to listen to what this device is transmitting, you don't know which frequency is going to be sent. And even the payload itself is not structured in the Sigfox protocol. Actually, the payload data is structured on the application side. So it could be two similar devices running at two different clients. Each one is receiving the data in a different format. So even if it's in the worst case scenario, you were able to detect at what time the device is going to send the information, at which frequency he can send. And it was not even encrypted. Just intercepting the payload at the radio communication side means that you need to identify where is the location of that device. And second, if you intercept it, you are not able to interrupt the payload because it's not structured in the protocol. So it depends how the customer side have structured that payload. Secure transmit, and then from the cloud to the customer application using HTTPS and callbacks and APIs, which are using security as well for the callbacks. So we have trusted the communication, of course, between the authentication between the device and the base station. We have, or between the network, there is anti-replay mechanism, and there is message integrity and payload encryption capabilities, as mentioned. If we talk about authentication and integrity, so the message sender, we always authenticate the message itself through the cloud. We ensure no anti-replay is being done because there is a message sequence that is being inserted in each message sent by the device. So you cannot really replay that message because the message sequence will not be compatible with what we have in the cloud side. So in that case, there is what we call a authentication code capability that is being generated at the device side with the algorithm and the key that is available for each device. And that MAC is sent with the message and being resolved on the other side at the receiving end to ensure that this authentication between the device and the cloud infrastructure, that this is actually the device that was defined, and that's the exact key, and this message is coming from that device. In the case of the encrypt the payload, as I mentioned, either using the Sigfox protocol stack, or more recently, we are able to use also secure elements, where you can have your own or implement secure elements for your key infrastructure as well for the devices. From an IT perspective, for reliability and resiliency, we have 2 data centers back to back, and connected with diverse connectivities, and 2 different hosting centers to ensure that the uptime of the network is guaranteed. We have lots of people coming, experts from security, in security from different companies as part of our teams that are in the R&D. We have lots of also partners as part of our ecosystem who have lots of security, specialization that could help anybody who is interested to deploy a solution and have a concern on security, would like to ensure maximum security for their application. They can consult with any of our partners who have been part of our partner network. The base station itself is IP protected, with integration between the OS and hardware itself, as well as using TPM for ensuring the integration between the base station network and the cloud infrastructure. So there is any attempt, if somebody wants to change the OS, the base station does not operate anymore, and does not allow communication back to the cloud if there is any issues related to this one, which is definitely far from reality, but actually it's something to ensure that in the field the base stations are also secured without any intervention from outside. So as I mentioned, there is lots of things we are doing in terms of security that ensures that in the future we are bringing the latest and available security technologies to our ecosystem. So as I mentioned, there will be now we are able to offer secure elements for devices. So people who would like to implement secure to do so now, and encrypting the payload to the base stations. And the base station itself is HSM, hardware security module is part of it, and ensures that the IPR and the IP technology of Sigfox are not stolen. And there is, of course, at the customer infrastructure, there is always the possibility to add their own side of the story in terms of putting their own security measures and using their own cryptography algorithms as well. So we still have, I'm not sure if we still have more time to go through the ecosystem, but I'll try to quickly address that, because I believe it's something that is always exciting for people who are interested to work on the device side. So we have also partners that are doing the protocols related to the Sigfox and integrating that in their chipsets, transceivers, and modules to offer it to device manufacturers who can integrate those what we call certified modules into their device and be able to deploy their devices in any place where the Sigfox has a network. So, and that's the beauty of our ecosystem partner, because anybody who's managing or doing devices and technologies related to Sigfox able to deploy this in any of the countries that Sigfox network. And today we have 36 countries that are either fully covered or in the process of being fully covered. And this opens new markets for device makers and people who are working in IoT to be able to also not address only the local market, but also export their technology and products to the global market where there's Sigfox. Of course, we are doing this certification aspect to ensure the quality and making sure that all device and ecosystem partners are compliant to the unlicensed spectrum regulations and make sure that devices are transmitting in the right quality and the right with respecting to those spectrum regulations, and ensure that the emissions and things like that is well taken care of. And also because of the security of making sure that no gray devices are deployed in the network, we have to do this security because certification, because we need to give and provide the device manufacturer with their unique ID for each of their devices, which at that time is made available after the certification. So we have 3 levels of certification. We have what we call the Sigfox verified, and this happens to the chipset manufacturers and module makers like the Texas Instrument, Intel, NXP, and so on. Manufacturers who are using a Sigfox verified module or are developing IoT platforms on the side of receiving the customer data. And each and every platform will have the Sigfox ready certifications in order to be able to connect to our cloud infrastructure. These are some of the chip and module partners that we have already in place. So as you can see, we have lots of well-known semiconductors vendors and makers, chip and modules that have already Sigfox verified modules there. We have lots of other partners who are integrating these chip and modules in their devices and able to sell a device with Sigfox integrated modules. And in terms of platforms, also we have lots of platform providers, including Master of Things, which is the first and currently the only Egyptian company that has been a pioneer with Sigfox, and they have been one of the first platform providers that have been certified for Sigfox back in 2015. Moving forward, so we have, of course, part of our ecosystem, we have the Sigfox partner network. So anybody who's doing devices is able to put those devices on the Sigfox partner network. For any customer or operator or Sigfox operator in the globe is able to access this partner network to get in touch with the manufacturers or the makers of the devices and see the prices and make orders and contacts for their customers on a global level. So this is part of our offering to ecosystem partners. We have also partnerships with development kit doers like Telit and Atmail, all having development kits for people who are into device making and want to start making and conceptualize devices and test it. So there is lots of development kits that are available, and most recently Ordino as well. And then pretty much at the end, you make a device, you try to get the chip and module, certify it, integrate it in the device, subscribe to a Sigfox service whenever there is a Sigfox operator in a country, and then it's immediately you connect and your device starts working. So we're trying to make it as simple as possible in terms of getting a Sigfox device available and certified and connected to our network. And of course, you can use the API data access for retrieving the information from the cloud system. So pretty much, I will show you some of the use cases which we have with our partners addressed. So there is across board in agriculture, in service and vehicle monitoring, in smart building and security, road structure and public transport. Lots of use cases from different partners. I would talk mainly about meters because it's something also of interest in the Egyptian market. There is lots of people who are either doing a full-scale meter, like the Camstrap, for example. Here they have a full smart meter integrated with Sigfox chip. Or there are also people who are doing retrofit devices that can be integrated into the classical analog there's lots of innovative solutions when it comes to deploying IoT that does not mean that you have to, remove and replace the whole existing infrastructure. You can put retrofit solutions to manage the existing infrastructure without the need to replace it. The same thing happens for electricity meters as well, and I think these are one of the key use cases, especially in the region of Middle East and Africa, that when it comes to smart utilities, that's one of the key IoT use cases that most companies and most governments are as a first step and deployment of IoT. Moving forward, there is also another in marking. As you can see, this is very neat and nifty solutions, because using wireless technology for smart things means that if you have coverage in an area, all you need to get is the device and install it, and it's working immediately. There is no need to dig and and distract the things for putting specific infrastructure to cover such a location for just putting one use case. You are using a public available network that is covering the area, and you are just focusing on deploying the solution immediately using wireless communication. So this is another water level monitoring, could be a gas monitoring, could be petrol monitoring, whatever the need is. So there will be a sensor that can be inserted and measuring the level of water or flow or consumptions, and sending alerts whenever it reaches a certain level for the redeployment or for refilling. What else? This is another one in healthcare, like this small watch in the middle fall detector. It was done as a pilot for seniors and disabled people who might be living alone, or they have fell, and it sends alerts if they have fallen. It also have GPS location and coordinates to provide what we call geofencing. If he moves around outside a certain area for certain reasons, there is a panic button. So different use cases. Another one for smart homes, there is the one here, SmokeU. Like this is a smoke detector device that is wirelessly operating using the Sigfox. You can just stick in any of your rooms in the house, and once it detects smokes, sends you an alert signal. There is water leak detection. There is water quality monitoring, for example, swimming pools or drinking water. Lots of ideas and things are made possible with using the Sigfox technology and the low power WAN connectivity that we are offering. Here in agriculture, for example, smart agriculture sensors to measure the soil temperature, humidity, and water in the field to decide on precise, agriculture and watering of fields. There is connected beehives, for example, for beehives. You don't need to go and check if the thing is full. It just sends you an alert whenever it is full, and you go and pick it up. So lots of interesting use cases. Here, structural health monitoring on the down right side. This is for all buildings. It see if there is any cracks and if there is any tilts happening in the building, and detects any additional deterioration in the building health itself and sends alarms. The one and the predictive maintenance when it comes to railway application. So sometimes it gets tilted because of change of temperature, and sends alerts for the maintenance or for the train drivers to slow in certain situations. So lots of interesting use cases. My last part, I think, which is quite important as well, which is the regulatory regime and why we need to look at the regulatory side for fostering innovation. Because for us, the regulatory environment that allows you to operate in a very good and efficient way means it allows you to be able to foster in that fostering the ecosystem and coming up with new ideas to solve current and today's problem. So if we look at the spectrum that we use in terms of the ISM band, it will be in the 868 megahertz, which is called the SRD RFID ISM band, and they call it the unlicensed Sigfox operate in the Europe, Middle East, and Africa regions. I believe that on the side of the different technologies used for the wide area coverage between the dedicated spectrum and the shared spectrum, we all understand that mobile network with the extended coverage GSM or narrowband IoT uses different frequencies which are dedicated for them. So each operator will have to go and apply for a dedicated bandwidth within that spectrum range to achieve the same not the case for the shared spectrum, because it's similar to the Wi-Fi spectrum shared among different technologies, and they can coexist within the same spectrum as long as you are respecting the regulations of the use and the duty cycle and power transmitted. So in general, there is a different licensing regime. The light licensing regime is always done in cases when something new is happening to try to ensure that the deployment is done on a very good, without any hindrance and uphill tasks for the operator or the investors who are trying to foster this innovation and ecosystem. It also allows that lots of IoT new startups come into the picture and foster the ecosystem and economy of a specific territory, because as mentioned, this IoT is a global thing, and a device is made in Egypt today, for example, can be easily deployed once it's certified by Sigfox, can be easily deployed in any of the existing markets today in the globe, which has Sigfox coverage. And actually, one of the current weaknesses of the ecosystem of IoT is that most of the companies that are working in this are all startups, and they don't have the scales and the means yet to go global and support deployments across the board. So the more ecosystem partners comes into the picture, the more the regulations allow them to operate freely and make sure that it fosters innovations. It will help expand the economical contribution of such startups to the economy of a specific country. And at the end, I believe that in Europe, which is have lots of advanced regulations when it comes to IoT, it was talking about innovation, and it was enabled by design, as the process for accessing the market is quite flexible there, and you don't need a lot of approvals and license requirements to be able to operate an IoT network in such regions. Of course, in the Middle East and other regions as well, Africa and some of the East Asia regions, they have more stringent regulations when it comes to deploying public networks. They don't have a necessity by say that they have an IoT specific regulations, but they usually use the telecommunication existing license, which I believe is not well suited at this new evolution of IoT operators that is coming into the market, because it addresses a different issue. But we have been very pragmatic when it comes to addressing this, working closely with regulators and the local partners there to be able to put new ideas in the existing regulations to try to foster this whole framework to adopt low power WAN, opening the access to the shared spectrum of the ISM band. And lots of countries have seen the benefit by opening such kind of regulations and putting the necessary definitions. as much as I can. So I've got lots of questions here coming. So Sigfox provides software to connect devices or provides the device themselves, I think from Nuran. In that case, I believe Sigfox provides the library software, which has to do with the radio communication, and it is targeted towards the device makers themselves, who are not the device makers, but actually the chip makers, who are able to integrate the Sigfox library in such chipsets, and then the device makers make use of those chipsets into their devices. The devices usually have a different function, which could be sensing, could be a device for smart metering, could be any other device to integrate the Sigfox module and technology to be able to communicate over the Sigfox network. So we don't offer the devices as such. It's our partners who are integrating the Sigfox library and technology into their products that they get it from Sigfox. I need to ask, use Sigfox IoT technology in GPS tracking, especially kids tracking. For example, parents need to keep track of GPS location of their kids. What device, system, software, etc. will be used and cost? Also, what is the legality for this solution and technology? Okay, so GPS is a location, it's some part of a chip that can be integrated in any device. Sigfox technology can use geolocation using the network, or can be integrated with GPS trackers, existing GPS trackers, whatever that could be, and to send the location to the application, whatever that application could be, on a smartphone, could be on a web page, or could be a different application that the use case itself. So Sigfox is all about the communication component of a device that does a function in that sense, and hence the GPS location is sent through the GPS tracker using the Sigfox technology itself. With regard to the legality for this solution, I mean, each country has its own regulation, so it depends on the situation here in Egypt. But I think there is lots of other countries who have similar solutions, and not necessarily that is deployed on a country-wide basis, but rather in specific locations. So what is the status now in Egypt about Sigfox? Today, the status that we have been exploring, what are the current regulations regarding having an IoT network in Egypt. So we have lots of meetings happening with to try to understand what could potentially be the requirements, and if the spectrum, the unlicensed spectrum, has been opened or about to be opened for such an opportunity. But as of today, there is yet no network in Egypt for Sigfox, but we are hoping that in the near future that will not be the case, because this means that with all the initiative the government is addressing and trying to do with smart cities, we hope that the vision is all about trying to bring different technologies to address the current available requirements. I need to ask, how can we use Sigfox IoT technology in GPS tracking? I think this is the same question as before I addressed. So as of today, so there's a question: what are the best Egyptian startups that are already working on Sigfox? I mean, I think Egypt has a lot of potential when it comes to working with Sigfox. Of course, the lack of a network in Egypt is causing a little bit of delay. Nevertheless, there is also solutions from Sigfox that allows you to start working on developing either platforms or softwares or devices using the Sigfox technology as of today, and we provide lots of materials and support for that. We are still at the early phases, but we have been talking to lots of the incubators in Egypt, which are actually very well established and have lots of ideas and programs today for IoT, and we are trying to work with them closely to bring Sigfox technology into the country, in coordination, of course, with the regulator in Egypt, because without having the regulators approving the technology to be entering into Egypt is something that is, of course, delaying a little bit working on a massive scale with Sigfox in Egypt today. So we need more resources about building solution architecture. I think one of the good references is going to the partner network at Sigfox site. You can go online and start looking at how to build a solution using the online resources there. There's lots of material that you can address. And of course, you can always get in touch with us in Sigfox, and we will guide you through what needs to be done to become a solution provider or a device maker. What is about LoRa? Sigfox was always mentioned beside the LoRa network. What is the main difference between them? Okay, LoRa and Sigfox are both low power WAN technologies. The difference between them is the way they transmit and the use of the spectrum. They all work in the unlicensed band. There is different models. LoRa is a consortium of companies who are members on trying to make what we call a LoRa standard, with contribution from different alliances. So they have this, what's called LoRa Alliance. LoRa is mainly driven by Semtech, which is a chip manufacturer who is manufacturing this LoRa chip. So the approach and the business models are quite different. Not necessarily the technology itself, it's both low power WAN, but Sigfox is all about countrywide public networks, not private networks. I believe LoRa is more of private network with minimal countrywide deployments, which means it's done on a private basis for a specific use case for a specific customers, and not like Sigfox, which operates on a business model which has to do with the public network. I think that was the last question for today. So thank you very much for the time and listening. And if there is any further questions, I can be able to take them offline. You have my email, and thank you very much for your listening.